Okay, so what's the difference between continuous and discrete case? So how you want to differentiate between these two is when the benefits payable at the moment of death. So the keywords is moment of death. So it is for continuous case. And then for the continuous case that we already learned before, where we have to use the integration. However, if the case for the insurance payable at the end of the year of death, it for discrete case. Since we already know the actual time, because whenever it happened between that particular year, we always pay in December for that year. But for the moment of death, we need the interval, because we will pay at the moment of death. The death can happen in January, in February, or in May. So we don't know. We have to pay in the interval of that particular year. So that's why we need the integration, because in the integration, we have the bound, the lower bound and the upper bound. So before this, we use T for the time of death. Okay, so we have BT, we have VT, we have ZT for the benefit. However, now we use K. Okay, so we use K. So BK plus 1 is for the benefit amount payable. So in the continuous, we use BT. So it means the same thing, but we use different variable. However, we start with plus 1. Okay, why we start with plus 1? Because it's starting from t equal to 1 at the end of that year. So it's not from 0. So we plus 1. So VK also we have to plus with 1. So before this, we use VT. So we use VT in continuous. So K plus 1 means that when it happens from K to K plus 1, so we will pay at K plus 1 at the end of the year. And then ZK plus 1 is the present value. It's the present value of the policy issue of the benefit. Okay, ZK plus 1. So before this, we use ZT. Okay. So before this, when we want to calculate the actuarial present value, or we also call it as net single premium, so we use the integration, but now we have to use summation. Okay, summation. So in the summation still consists of the same components in the integration. So we have VT, TPX, mu x plus T to find the APV for the continuous. But for the discrete, we have VK plus 1, KPX, QX plus K. Okay, now while we're starting from K plus 1, if we start from K, so K is equal to 0, becomes 0. So the power of 0 becomes 1. That's why we start from 1. So because K is equal to 0, so if we start from K, so the discounted function become 1. So that's why we take plus 1. Since we start from 0, so we end. So the end of the interval is until n minus 1. It's not n, because we start from 0. Okay. So the second moment of death, the second moment for n years, the second moment to calculate the variance, we need the second moment of term. This is for the term insurance case. Okay, this is for the first one is for n year term insurance. So that's why we have the limit. Okay, so the limit until n minus 1. Same as continuous for the continuous insurance. For term insurance, we have to integrate from 0 to n. Okay, so for discrete, we have to take from 0 to n minus 1. for term insurance. So the difference with the notation is difference between continuous and also for the discrete. So for the discrete, we don't have bar on the top of A. So this is term insurance. Still, we have 1 on an X, but we don't have bar for the discrete. So when you look at this notation, so you know that this is for discrete case for term insurance. So for continuous for term insurance is A bar X N. But for discrete, we don't have that bar. We don't have this bar. Okay, so that's the difference. So you have to write the correct notation. Okay, so if you write incorrect notation, so it will give different meaning. Okay, so the second moment, to find the variance, we need the second moment. So we use 2 delta. Okay, instead of 1 delta. So the VK here is actually this discounted function. So E negative delta. Okay, this is the recursive relationship. So you just ignore this. And the second one is for the whole life insurance. So for the whole life insurance, we calculate until infinity. So this is the formula for whole life insurance. So the notation is AX, okay, without the bar. So the difference between continuous and discrete. We start from K equal to 0, same as the term insurance. However, the upper bound is different. So the upper bound now we have omega minus X minus 1. Okay, in continuous for de Morse law case, we have to integrate 0 to omega minus X. Omega minus X for the de Morse law. But for the constant force, 0 until infinity. Okay, but if in the case that they give the interval already, so we know that the t is equal to 0 to 100. So you know the infinity value is equal to 100. So you put 100. So for the discrete case, the upper bound is same as the de Morse law omega minus X, but you have to put minus 1 because we start from K plus 1. Okay, 0 to omega minus X minus 1. Okay. Okay, this is commutation function. So you don't need to know how to prove this. Okay, how to prove this. Okay, it's not your part. So you just have to know the commutation function. Okay, so in actuarial, we have table. We have life table, where in the life table we have LX, the DX. Okay. For the continuous case, we can calculate using the integration. However, for the discrete case, if the period until 100 years, how you can summation from 0 to 100 or from 0 to 99 because we minus 1. It's just like tedious, right? We have to calculate 1 by 1 plus. So actuaries, they construct the table for the discrete case where we just have to refer to the table to solve for the long period. We can calculate if it's just like 0 to 5. If n equal to 5, we have just 5 term, isn't it? But if we have 100 term, so how can we solve that problem? So it comes from, if you still remember, we learned in the calculus about geometric series and also arithmetic series. Okay, arithmetic series for the summation. So the first term plus the last term divided with blah, blah, blah. Okay. So it comes from that. So the actuaries already construct the table. But before we can refer to the table, we have to change first into the commutation function. Okay, so we call the big MX and the big DX is as the commutation function. Okay, so for the insurance, for the life insurance, we have term, we have whole life insurance, and also we have endowment. So endowment actually is, sorry, endowment we don't have. Okay, endowment actually is the combination of term plus pure endowment. Okay, so this is for death benefit. This for survive benefit. Okay, so how we want to transform this to commutation function? So M here is represent the number of death. It is actually the summation of dx, dx with the discounted value. So the term for discounted function, and also the dx is number of death. We learned already in life table. So the summation, all this plus, it becomes cx, and the cx plus, it becomes mx. But you just have to know the mx. So mx represent the summation of the discounted function times the number of death divided with the number of survivors, so lx. So it's just the summation of those. So you know that the mx referring to the death case. So mx is for the death. It is the summation of the number of death times the discounted function from 0 until 100. If the life table, we always use until 100. So 100 components, okay? 100 components of this, we get the CX, and then we get the MX. So you don't need to know how to get the CX, how it becomes the DX. So you just have to know MX, the final product, the MX, referring to the death cases. Because in annuity, we also have commutation function for the discrete. So you have to watch my video in the last part 3. So you will meet this case for the discrete, for the life annuity. So that one is for the survival. But this one, the MX is for the death case. So sorry, it's not including the VX and LX, just the numerator. So the DX times the VX plus, it becomes CX, and then it becomes MX. Okay. However, the LX is the number of survivors times the discounted function. So it becomes the big DX. So big DX is not equal to the small dx. So small dx for number of death, the big dx is the summation of discounted function and the survivors. So it about the survivors, So the big dx is about the survivors. Okay, it's about the survivors. So to find the AX, to find the whole life, you have to take mx over dx. How to calculate the mx dx? This one you can refer to the table. Let's say x is equal to 60. So m60 over d60. Okay, so for the term case, we have mx minus mx plus n over dx, over the dx. So because we have limited, we only have limited period from x to x plus n for the term insurance. So this one you also can, if let's say m equal to x equal to 60, n equal to 5, or 5 we can calculate using the summation. So let's say n is equal to 10. So m60 minus m70 over d60. So this is for term insurance. Then we can refer to the table. So I will show you the life table, the illustrative life table, the same life table that we use in chapter 2. So far, do you have any question? Is it okay so far? It's just easy because we just have to refer to the table, but you have to know which formula that you have to use for that particular case. If it is whole life insurance, so you need to use the formula for whole life insurance. I'm looking for my illustrative life table. Yes, here. Okay. So you can open your illustrative life table, ILT, that I already give you in chapter 2. Share. Okay. Okay, can you see my table? Okay, so before this, we only use LX and DX in the life table. So if you go to next page, we also have becomes 2. We also have the value for dx here. So dx, so now we need mx and dx. So dx and also mx. Okay, here is for mx. Let's say we want to find A60, the whole life insurance for an individual age 60. So M60 over D60. So you find M60 here. So M in the middle column. So M60 here is 916.2423. So divide with D60. So we find D. Okay, D here. So D60 is 2432.16. So you divide, so you can get the A60. Then let's say we have benefit. So we times with the benefit. If benefit is equal to 10,000, so you times with 10,000 after you get the values M60 over D60. Okay. Stop sharing. Okay, let's say I give you another type of life table, okay, because we have many type of life table. So this is only one example. So you still have to refer to the same thing, because every life table, we have the LX, we have the DX, we have the big MX, we have the big DX. Okay. Okay, so you don't have to cover the recursive one. So the recursive one, so you don't need to know how what is the recursive one. And then we have endowment. So endowment, we have actually, this is for term. This is for term. And this is for pure endowment, VN and PX. So six. Oh, sorry, I'm not sharing. I'm not sharing. Okay, so the third one is for term endowment. So this is for term. This is for whole life. And third one is for endowment. So for endowment, we know that just same as the continuous case, the green highlight is for the term insurance. So it's starting from 0 to n-1. And this is for pure endowment. So this is for survival benefit. And this is for death benefit. Okay, so endowment, we have two. So if we want to use the commutation function, so the term insurance, you already know mx minus mx plus n over the dx. So what about pure endowment? So pure endowment is about survival benefit. So we cannot use the m. M is for the death thing, okay? M for the death thing, but D for the survival thing. So let's say we have endowment for A60 for 10 years. So endowment for X equal to 60, N equal to 10 years. So you have to find first for the term. So term is M60 minus MX plus N is 70 over D60. So the denominator must always use the current age. So plus, how to find the Vn and Px? It is dx plus n over dx. So D60 plus 10 is 70 over D60. So you can refer to the table. So for pure endowment, it is dx plus n over dx. So for term insurance, mx minus mx plus n over dx. We always have over dx because in the probability, when we want to find the TPX or the TQX, we always need the dx over lx to become from the number, become the probability. We have to divide with the number of survivors. So the dx is about the survive. It's not number of survivors because we already times with the discounted function, and then we summation the number of survive times the discounted function, and we already sum up, okay, from 0 to omega minus x. Okay, is it simple? So you don't worry about discrete case, okay? So, but you have to know to differentiate which is whether it is discrete case or continuous case. So the key word there is if the benefit payable at the end of the year of death, it is discrete case. And then you have to know how to write the correct notation. So you cannot write same as the continuous, okay? So the difference only the bar on the top of A, because there is marks for the notation. So for notation is very important in actual mathematics because it gives the different meaning. And then you have to know how to convert in commutation function. But let's say for the case less than 5 years, okay? So I asked you to calculate using this formula. So VK plus 1 KPX QX plus K. So we will try the example so you can see it more clearly. All right, this is the case where we need to use the summation. We cannot refer to the table because the table is already given, okay? Okay. So the first one is referring to the term insurance, So it is A56.3. So what is term insurance formula? So it becomes VK plus 1 KPX QX plus K. So we start from K equal to 0 and N minus 1. N minus 1. So if you substitute the age, it becomes K equal to 0, N is 3. So N here is 3. 3 minus 1 is 2. So VK plus 1 is equal to P56 K Q56 plus K. Then you can solve this problem. Okay, so we have the information of the PX. So this is for P55, P56, P57, P58, and P59. Okay, so for the first one, okay, so the summation 0 to 2. So we have the term for 0, 1, and also 2. So 0 to 2 is, so V, 0, we substitute 0 to K, it becomes 1. That's why we start from K plus 1. Since if we start from 0, K, so it becomes 0. So P56, so K is 0. So Q, when K is equal to 0, Q become 56. So plus V, K is equal to 1. So 1 plus 1 is 2. So now we have P56, K is equal to 1. So Q is 56 plus 1 is 57 plus V3 2P56 because K is equal to 2, Q is 58. Q is 58. Okay, so you solve one by one. So it must has 3 components since N is equal to 3. So N is equal to 3. So we have 3 components. 0, 1, and 2. When you substitute K equal to 0, and then K equal to 1, and then K equal to 2. Okay, so V1, V the power of 1, we already given V is equal to 0.75. So V is 0.75, the power of 1. So 0p56. So what is 0 p56? So here we have p56. Actually, here is we have 1. p56 to p57. So if we don't have number at the back, so you know that it is equal to 1. But we don't have p56 0. What does it mean by p56 0? So it means that L56 plus 0 over L56, isn't it? So because TPX is equal to LX plus T over LX. But now the T is equal to 0. So it becomes 1. It becomes 1. Okay, so the probability of the person at age 56 until 56 is still 1 because the time is not berjalan lagi. Okay, so it becomes 1. So Q56, since we already know the P56, so we also can find the Q56. So the Q56 is 1 minus P56. So 1 minus 0.9 is 0.1 plus. So V2, so V is 0.75, the power of 2. So P56, we already know, 0.9. So what is Q57? So Q57 we can find from the table, 1 minus P57. So P57 is 0.85. 1 minus 0.85 is 0.15. Okay, the last one is quite tricky. So V3 is 0.75, the power of 3. Okay, now, how can we calculate this one? 256. Because in the table, we only know the T is 1, okay? For each one, 56, 57. So do you still remember when I teach you about these things to P56? So the 2 referring to, we have 2 components, okay? Because we can calculate the multiplication of the, this is the multiplication, 0 to 2 for the px, which is we can times px times px plus 1 times px plus 2, blah, 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 until px time n minus 1. Okay, so I already teach you, if you don't want to get confused, so 2p56, we need 2 components starting from 56, it becomes 56 times p57. So we have 1, 2. Starting from the current age is 56. So 56 times p57. So now you can find here for 2p56, it becomes p56, sorry, I put here p56 times p57. So p56 is 0.9 times 0.8557. And then Q58 is 1 minus P58 is 1 minus 0.78 is 0.22. So the answer would be 0.2219. So this is how we find the discrete case, if we don't we don't refer to the table for the shorter period. For the live table, we have longer period, since now we only have 3 years. N is equal to 3, so it still can be able to compute one by one. So do you have any problems so far? Is it okay? So do you understand? Is it okay? Chua Sun Kai, is it okay with you? Can you see it more clearly after I show you the example? All right. So the second one is for the case of pure endowment. So for pure endowment, so for the pure endowment, okay. So for the case of pure endowment, you know that it is Vn and Px. So A56 3, so endowment, pure endowment. So we have Vn and Px. So we have Vn is equal to 3p 56. Okay, so just a simple one. So Vn and Px. So V3, we already know V is 0.75. So 0.75, the power of 3. So 3p56, you can use my formula, which is we need 3 components starting from 56, P56, P57, P58. So you can substitute all the values and you can find 56, 57, and 58 is 0.9, 0.85 times 0.78. So the answer is 0.2517. So I hope that you can see how to use the discrete formula in the problem. So the last one is A56 This is endowment. This is endowment. So A56 so we have to take term plus endowment. So the term is for A. So we take result from A plus the pure endowment is from B. So you just sum up this two values and you will get for the pure endowment. Okay, so this is all for A56 3 plus A56 3 for the actually supposedly I put the formula first and the answer is 0.4736. Okay. Okay, that is the case for if we don't refer to the left table and we have to find the summation by